Most tool batteries do not die on the day they stop charging. They lose useful power one hot afternoon, one frozen recharge, and one punishing overload at a time. The surprising part is that cycling is only half the story. A battery can age while doing absolutely nothing. In the next few minutes, we will separate the real battery killers from the internet myths and finish with 4 habits that are practical on a real job site. Battery researchers separate aging into 2 overlapping categories. Calendar aging happens with time, even when the pack is not being cycled. Cycle aging adds the stress of charging, discharging, heat generation, and changes inside the electrodes. Both can reduce capacity, so the pack runs for less time. Both can also raise internal resistance, so voltage sags more under load and the tool feels weaker even before the charge gauge looks empty. Heat is the common multiplier. Higher temperature speeds up unwanted side reactions in lithium-ion cells. That does not mean every chemistry fails at one magic temperature. The mechanism and boundary depend on the cell. It does mean a dark van, direct sunlight, or a metal shed in summer can be an aging chamber. An official DeWalt manual for the covered packs says not to store or use them where temperature may reach 40 degrees Celsius and recommends a cool, dry place. Temperature is not working alone. The Technical University of Munich stored 3 commercial 18650 cell types at 16 states of charge. High storage charge accelerated important calendar aging reactions, but the curve was not a simple straight line. Different chemistries showed different plateaus. So the useful conclusion is not a universal percentage. It is to avoid leaving a fully charged pack hot for long periods when that is practical, while still following the storage instructions for your exact battery system. Now pull the trigger on a grinder or saw. High current flows through every cell, connection, contact, and protection transistor. Internal resistance converts part of that electrical power into heat. The same resistance produces voltage sag, which is why a tired pack can make a tool feel weak under load. As cells age, resistance can rise, creating a feedback loop. More sag, more heating for the same job, and less useful power before the battery management system reaches a cutoff. Pack size can matter even inside the same voltage platform. When more cells are connected in parallel, the demanded current can be shared across more current paths. A compact pack may therefore work each cell harder during a high-power job than a larger compatible pack designed for that load. This is not permission to invent pack combinations or adapters. It is a reason to match high-demand tools with manufacturer-approved packs that are rated for the job, instead of assuming every pack with the same voltage label performs identically. After a hard cut, the charger does not need to be the battery's next stop. If the pack is hot, put it on a stable, dry, non-flammable surface and let it return to the charging range specified by the manufacturer. Do not improvise with water, a freezer, or a forced shortcut. Good chargers and packs may delay charging when temperature is outside their allowed window, but the protection strategy differs by brand. Cooling first reduces the thermal stress you're stacking on top of charging. Cold has a different trap. A cold battery may deliver less power temporarily, but charging it cold can be more serious. In experiments on commercial high-energy cells, charging aging increased as temperature fell from 25 degrees towards 0, with lithium deposition identified as the dominant mechanism in the studied range. Manufacturer limits are the practical rule. One DeWalt manual says not to charge below 4.5 degrees Celsius, while a Makita document specifies 10 to 40 degrees for that product. The opposite extreme also needs nuance. A pack should not be abandoned completely depleted. Self-discharge and the small standby consumption of electronics can push a deeply empty pack toward an undervoltage condition over a long storage period. The cited DeWalt manual explicitly says not to store its packs completely depleted, but do not convert that into an invented universal storage percentage. If your manufacturer specifies a storage procedure, that instruction wins. If it does not, keep the pack cool and check it periodically. A battery management system can monitor cell voltage, pack current, and temperature, then disconnect the pack when a limit is crossed. Texas Instruments documents those kinds of functions for a representative multi-series battery monitor. But a cutoff is not a time machine. It cannot replace lost cyclable lithium or rebuild damaged electrode surfaces. And not every brand divides protection between pack, tool, and charger in the same way. Treat the BMS as a last line of protection, not permission to keep a battery hot or overloaded. Some warning signs are not gradual. A cracked case, swelling, impact damage, liquid, unusual smell, or a pack that becomes abnormally hot should end normal use. Do not open it to inspect the cells and do not put it back on the charger to see what happens. Isolate it from combustible material without touching leaking contents. Then follow the battery maker's service and recycling instructions. Manufacturer safety documents explicitly warn against charging or using crushed, cracked, or deformed packs. Good storage is boring, and that is exactly the point. Choose a cool, dry indoor location away from direct sunlight and excess heat or cold. Protect exposed terminals from screws, keys, and other metal objects that could create a short circuit. Store packs outside a tool that might accidentally switch on, and use only compatible chargers. For long idle periods, follow the product manual and inspect the pack occasionally instead of forgetting it in a van or an unconditioned shed. You will often hear that every lithium battery must live between 20 and 80%. That is too neat for sealed tool packs. Research shows state of charge effects depend on chemistry, electrode design, temperature, and where the pack's own electronics set its usable window. Many tool packs only show a few gauge bars, not a precise storage setting. Use the research for direction. Avoid prolonged hot, full storage when practical. Use the manufacturer instructions for the actual procedure. The practical checklist is short. 1. Keep packs away from avoidable heat. 2. Use the approved tool and charger system because compatibility includes electronics and temperature limits, not just voltage. 3. After a high-power job, let a hot pack cool before charging, and let a frozen pack warm naturally into its permitted range. 4. Inspect for damage and retire suspect packs through the approved service or recycling route. These habits cost almost nothing and target the stresses the evidence actually supports. So what actually kills lithium tool batteries? Usually not one dramatic event. It is accumulated chemical aging, accelerated by heat, high storage charge, heavy current, cold charging, deep neglect, or physical damage. The exact limits belong to your battery manufacturer, but the hierarchy is clear. Control temperature, match the pack to the job, charge inside the approved window, and stop using damaged hardware. The charge gauge tells you how much energy is available today. Temperature and resistance help decide how much performance remains tomorrow.